In day 2 of the 1.6 notes, we're going to take the and or inequalities that we did previously, and we're going to combine it with the absolute value equations, which we covered in section 1.5. So the first thing to go over is at any time we see one of these two signs, a greater than or equal to sign, think great or than, with the main focus being on or. Okay, when we see a less than or equal to sign, think less thans, with a focus being on and. So what we have here is an absolute value inequality. These are really similar to absolute value equations like we had previously, except now instead of an equal sign, we have an inequality, which means we're going to have some shading in the graph. And the nice thing about these is that they're always going to take on one of two forms. Either it's going to be the outsides shaded, okay, or it's going to be the middle section that gets shaded. Okay, it's never going to be like just the right or just the left side or the middle and one of those two outside sections. Okay, and the way we figure out what it's going to look like is by this sign right here. So as I mentioned on the previous slide, when we look at this, we think less than. And by this time, we should know that and often takes the form of the middle section. Okay, so on our number line, we're going to have the middle section shaded in. We also have a less than or equal to sign, which means we're going to have colored in circles. So our graph's going to look like that. The only thing we need to figure out is what those two numbers are. And the way we do that is the same way we did it with absolute value equations. So we split it up into two parts and we do our two equations. So take the middle part, write it twice, 4x plus 8, 4x plus 8. Okay, now what absolute value means is it's going to be 20 away from 0. So we set that equal to 20 on one side and then negative 20 on the other side. And then we solve both of them. So minus 8, minus 8. Okay, and then just go through all these steps, solve each of them, and we get our two numbers. Make sure when we write this out, write the smaller number on the left, larger on the right. Number 2, same problem, except now we have a greater than sign. Think great or than. Or means it's going to be the outside sections. This time we have a greater than sign without that equal to sign, so it's going to be empty circles, outside sections, and just like the previous section, section 1.5, split these into two parts, solve each of those equations, and get our two numbers. All right, that's our solution. Now, sometimes it'll give us a graph and ask us to work backwards and come up with the equation or inequality that was used to create that graph. So if it gives us a graph like this, first thing we can figure out is the sign that was used to create it. This is the middle section, so this is a less than the graph, and we have colored in circles, so it's less than or equal to. Now, all absolute value inequalities follow the same form. It's x minus h, the sign that we're using, so it's a less than or equal to, and then k. H and k we get from the graph. H is going to be the center. It's exactly in between our two endpoints, and k is the distance from the center to those endpoints. All right, so in this case, the center is -1. We're going to put a -1 in for h. Okay, so to start off, we have x minus -1 is less than or equal to. K is how far are we moving from the center to each of these endpoints. Okay, so it's 2 away from the center to each of those endpoints, less than or equal to 2. So if we were to clean this up, okay, here we have minus a negative, so we could write it as x plus 1 inside the absolute value is less than or equal to 2. As a final example, let's apply it to a word problem. A professional basketball should weigh 21 ounces with a tolerance of 1 ounce, inclusive. Write an absolute value inequality to represent this problem. So let's start off by drawing out what this problem says. Okay, so we want the basketball to weigh 21 ounces, but we're saying it's okay for it to have a tolerance of 1 ounce. So it's okay if it weighs within 1 ounce of 21 ounces. The word inclusive means that it's all right if it weighs 22 ounces. Exclusive would mean that it's not okay. So in other words, these circles are going to be colored in. Okay, if we subtract 1 from 21, we'd be at 20, and the range of acceptable values is in between those two. So that's our graph. Okay, again, we're using this form. This is the middle again, so it's another less than or equal to problem. And then we're just going to plug everything in. So we have the center, which is 21, and from the center to the endpoint is 1. So our absolute value inequality would be absolute value of x minus 21 is less than or equal to 1.